attention please, bomb calorimeter. We are hearing this particular term second time in just a very short gap of 3 or 4 lectures. This is Ujash lecture is the 4th lecture. We have the lecture from Penal and we have the lecture from Vaishnavi and the 3rd lecture from our friend Devansh. This is the 4th lecture. In spite of the very fact that we have heard only 4 lectures, 4 out of 2 hota hai 50%. You should understand the significance of this technique. To know the energy content of a particular material, we use bomb calorimeter. Okay, a closed vessel. And you should have a thorough knowledge of this instrument. Okay, go ahead, please.
Introduction. So basically, this experiment was based on the principle that if can biodiesel be used as an alternative for petroleum-based fuels or not.
Yeah, have you understood? This is the heart of the paper. This is the core of the paper. How sustainable is biodiesel as a substitute to conventional fossil fuels? That's what Ujash has highlighted. The highlight of the paper is, can we use biodiesel as a substitute to conventional fuels like gasoline, okay, kerosene and jet fuels? Please go ahead.
The procurement of alternative fuel resources is an area of growing concern due to the rising energy demands of the growing population. One of the possible solutions to this problem is the use of biodiesel as an alternative to the petroleum-based diesel fuels currently in use today. A variable solution is especially important in the Department of Defense due to the incredible annual fuel needs to power military vehicles and aircrafts. The benefits of using biodiesel versus petroleum-based diesel are numerous, including reduced sulfur and carbon monoxide emission, renewability, and better combustion. However, there are challenges that must be overcome concerning biodiesel. First, higher emission of nitrogen oxide, higher production costs, and problematic cold flow properties. Therefore, we have envisioned a project for upper-level undergraduates wherein students use their synthetic skills to produce samples of biodiesel and then employ analytical and physical chemistry skills to analyze the synthetic biodiesel products in comparison with several conventional petroleum-based fuel sources. In this study, we analyzed several different synthetic biodiesel (BD) fuels obtained through base-catalyzed trans-esterification. In addition, several conventional petroleum-based fuels were chosen for comparative analysis, including number 2 diesel, kerosene, and JP8, that is jet propellant of jet fuel. A typical fuel profile was developed that is inclusive of the following characteristics: density, refractive index, viscosity, and cold flow properties. This project also involved an emphasis on combustion properties and the effect of fatty acid methyl ester (FAME).
Excuse me, Ujash. Please make a note of fatty acid methyl ester. This is the keyword. This is the chemical name of biodiesel. Biodiesel is commercial name of the fuel. Okay, do not convey anything regarding the chemical composition of the fuel. The chemical composition of biodiesel is fatty acid methyl ester. Fatty acid methyl ester. Okay, that is what is called biodiesel. FAME. Biodiesel is all chemists will call biodiesel as FAME. FAME. Fatty acid methyl ester. Okay, so fatty acid methyl ester and biodiesel are synonymous to each other. They are not different. Okay, chemists should always call biodiesel as fatty acid methyl ester, at least in the laboratory, at least in the class. If you go to petrol bunk and ask, give me fatty acid methyl ester, they will laugh at us. We should know what term to use where. Okay, my teacher has told that biodiesel is fatty acid methyl ester, so I will call fatty acid methyl ester in petrol diesel. Nobody will know that. They are not matured enough. Our population is not educated enough. No, they do not know the chemical composition. They do not know the chemical constituents. India is not an educated nation. What is the place of Israel in world's most educated population? Israel ranks 5th place in the world. World's most educated population. Our population, I do not know India where it stands, but as of now we have many problems, including education for children. as you know, youngsters, all these concerns should be in your mind, so that you know, when you become scientists, when you become bureaucrats, when you become politicians, when you become police officers, you will try to solve the problems of the society. This is one of the attempt to make you aware of the problems India is facing. We face absolute energy insecurity. Politicians will say we are ruling the nation for past 8 years. We have made India self-sustainable in energy. Do not ever believe the figures and the facts do not reflect the truth. This is elections are going to come. This is the election propaganda. But truly, see the Sri Lanka situation. Why are we not able to extend helping hand to Sri Lanka? We ourselves have deficiency of energy sources. So when politicians says we have attained self-sufficiency in energy, do not ever believe. If we were to attain self-sufficiency in energy, why the petrol prices are hiking? Why the diesel prices are hiking? Why the LPG prices are hiking? Have you ever heard in the news that petroleum price is reduced by 1 rupee? Have you ever heard in the news that LPG price is reduced by 1 rupee? Have you ever heard in the news that the bus fare is reduced by 2 rupees? No. Where is energy sufficiency? Where is self-reliance in energy? All these are a political propaganda. I object. Please go ahead.
Students explore the chemical composition of the fuels through GC-MS analysis and use that information in conjunction with molecular orbital package (MOPAC) molecular modeling to generate a thermochemical profile for each fuel.
Yeah, please listen. Here, Ujash is trying to show us a new avenue and the current trend in chemical research. Tomorrow you are going to be researchers. You should not be purely, focusing on experiments. Ujash is telling, in addition to doing laboratory experiment, we should have some theoretical knowledge also, and we should be able to explore theoretical techniques like MOPAC, molecular orbital package, some theoretical studies, modeling studies to substantiate our experimental results. That's what Ujash is trying to convey.
Experiment overview. The objective of this experiment is to prepare samples of BD and to conduct a comparative analysis of the biodiesel products with conventional fuel sources. The specific goal: preparation of biodiesel from several feedstocks using base catalyzed trans-esterification chemistry, determination of physical properties of fuel samples by collecting refractive index, density, viscometry, and cloud point data, evaluation of theoretical and empirical heats of combustion of the fuels by MOPAC modeling and bomb calorimetry. Experiment. The project as described herein occurs over 5 2-hour lessons, 10 total lab hours. In a more traditional setting.
Excuse me, Ujash. Please have in your mind, I am very sure in the days to come, Vaishnavi will become a great professor. You should have such idea, how to develop laboratory courses. One of our beloved faculty members, Viras sir, that has left us, Viras sir has developed many laboratory classes, experiments. You should have that aspect in your mind. Journal of Chemical Education is related to pedagogy, pedagogical skills, developing teaching abilities in lab and in theory. You see, what the authors intended to convey us is in undergraduate laboratory. I do not know what laboratory classes you are doing in organic chemistry, but such a study can be included. That's what they mean. Like how to estimate the amount of bioethanol in gasoline can be one experiment. How to estimate, how to produce bioethanol and separate bioethanol from glycerol, from catalyst, the base catalyst. That's what Ujash has told. In this particular paper, a base catalyst is used. It could be NaOH, it could be KOH, it could be simply calcium oxide. India has rich mineral wealth. Calcium carbonate mines are there in India. From calcium carbonate we can easily get calcium oxide. Vaishnavi, how can we get calcium oxide from calcium carbonate? By combustion, CaCO3 gives rise to CaO plus CO2. Emission of CO2. Even eggshells are rich in calcium carbonate. When eggshells are burned, combusted at high temperature, what do we get? Calcium oxide. These calcium oxide catalysts are less expensive and they are very active for biodiesel production. Okay, this knowledge you should have in your mind. Such laboratory classes can be developed for first BSc, second BSc, like that. Please, Ujash, go ahead.
In a more traditional setting, the entire project would be accomplished within a 3x3 hour period. The first lesson is dedicated to the isolation of sunflower oil from 20 grams of sunflower seeds by first 9 days.
Excuse me, Ujash. The moment you hear sunflower oil, what comes to your mind? Monday? The moment you hear sunflower oil, what comes to your mind? Ukraine war. War in Ukraine. Yeah, Ukraine is the source for sunflower oil. What is the chief agricultural product of Ukraine? Sunflower oil. Because of that only, because Ukraine is the granary of food. Yes, you said, Parag has said correctly only food only, but food is everywhere. In Ukraine especially, Ukraine is such a blessed nation that Ukraine produces world largest sunflower oil and exports food to many European countries. Today, if you hear the news, I think most of you have heard the news. What is the bad news today? Vladimir Putin is threatening Russia, Ukraine, that he will cut off electricity supply so that Ukrainians will not have refrigerated food. Ukrainians will not have, if the electricity is not there, we cannot warm up our houses. Ukraine is such a cold country. I have been in China, I have been in Korea. I know the problems of being, in cold countries. They need warmth, they need fireplace, Putin is simply threatening that he will cut off electricity so that the Ukrainians will be starved of food and starved of electricity. Can Putin do anything? If God is for us, who can be against us? Very, very bad people, Can you think of such bad things for a neighbor? I object this. No, this is not good for world. What United Nations is doing. When Putin is threatening a nation, a sovereign nation, an independent nation, it is today Ukraine. Tomorrow it could be, God forbid, India. No, Nazis did. The Nazis only stopped with Germany. They did extend their dominion over almost all of the European countries. Agreed? Yeah, Putin will not stop with Ukraine, mind you. Continue.
The extraction in hexanes nominally requires 1 hour to obtain an acceptable amount of sunflower oil. If time permits, the socklet extraction can be left for an extended period of time, perhaps until the end of the day, and then stop. This option would require the student to return to the lab outside of normal contact time to attend to the extraction. However, this is the only process that would engage students outside of the normal laboratory hours. The extraction period affords time for the instructor to demonstrate the MOPAC modeling of fuel components or the use or calibration of the bomb calorimeter. During the second lesson, the remainder of the BD samples is prepared by base catalyzed transesterification. The synthesis and isolation of biodiesel requires an additional 1.5 to 2 hours of clock time, but can be reasonably accomplished during the second lesson.
Excuse me, Ujash, here I have something to ask. Bharat, what is BD? What is BD? Biodiesel. Yeah, are you following the lecture of Ujash? We are not here for time pass activity. Ujash has spent much of her time. We should follow carefully. Tomorrow, Bharat will spend much of her time in present. So whenever a student is present, you should try to, you should try to get inspiration from them. It's not so easy to stand at the podium, to prepare the PowerPoint presentation. You may think that it is simply cut copy paste. Even cut copy paste needs some time, needs some skill, So you should honor the speaker by giving your 100% attention. Yeah, one more thing. In the previous slide, Ujash has told that for doing the transesterification it takes 2.5 to 3 hours. No, I will use a microwave. I will use solid base catalyst like strontium oxide. I can do transesterification reaction in a batch in 1 minute. No, it should be in your mind. You will be surprised. In all of the Journal of Chemical Education journal, when I search with the keyword biodiesel, how many papers do you expect? Can anyone guess how many results I have with the keyword biodiesel? I would have expected, even thousands. It is such a hot topic, but Journal of Chemical Education is different because it's not a research journal. It is a teaching journal. In the emblem of GSFC University, what do you say? GSFC University Education Revision. What?
Education re-envision.
Yeah, thank you. You see, that makes Ujash a leader. Education re-envisioned. Yeah, education. Thank you. Education re-envisioned. Okay, this is what is called, in chemical education journal, the education is re-envisioned. It's a different vision the scientists present. That is why I opted Journal of Chemical Education. There are thousands of journals. Did I bring any journal here? I can bring nature, I can bring science. In fact, I wanted to try that experiment. But you are too young for that. Nature, science, to understand it may take some time for you. So I opted a paper matching your level, matching your knowledge. At the same time, having best quality. I want such standard papers to be presented in our class. Okay. As Ujash has told, biodiesel, doesn't require 3 to 4 hours. I am a researcher, extensively worked on biodiesel. I have produced nearly 4 papers or 5 papers on this subject recently. And microwave is the best technology, Ujash. Using microwave, we can produce biodiesel in minutes, not hours. Okay, yes, please go ahead, Ujash.
The next several lessons are devoted to the analysis of the fuels. With an extended laboratory time, we would expect the complete analysis would be accomplished easily within 2 cross 3 hour period, with warm calorimeter being the most time-consuming. We would advise an additional period for instructions on how to execute calculations using the provided warm calorimeter data workup template. Following the laboratory work, students interpreted results by way of comparative analysis and then use that information to write a mock memorandum to Air Force leadership documenting their findings and proposing a recommendation for alternative fuel use. This exercise requires some out-of-class time to complete, but this is in line with the normal commitment for writing an undergraduate laboratory report. Hazards of this experiment. All organic solvents in the experiment include flammable liquids that are toxic by inhalation. Prudent use of personal protective equipment is recommended, and all manipulations described here were carried out in the standard operating fuel code. Always consult the material safety data sheet.
Yeah, excuse me. Now Ujash is introducing to us a very, very useful term for chemists, that is MSDS. Material Safety Data Sheet. Okay, in audits, in any standard suppliers of chemicals, along with chemicals, we always have MSDS, Materials Safety Data Sheet. Okay, this has to be carefully read when we use any new chemical. At this age, as undergraduate students, the quantum of chemicals you might have handled will be relatively less. So you have to learn that MSDS is inevitable for you to read before you start using any new chemical. Please go ahead, Ujash.
For chemicals, before executing this laboratory with reference CAS numbers, students should avoid chemical contact by wearing gloves and working in an adequate fume-proof environment, especially as it pertains to the following chemicals: chloroform, dichloromethane, methanol, hexanes, and sodium hydroxide. Particular attention should be paid to the executing the warm calorimeter, and it is very important to never overload the
Listen, this is very important precaution. You know, whenever you operate pressure reactors, power reactors, you have to depressurize, come to atmospheric pressure. The pressure should be in equilibrium with atmospheric pressure. Only then you should attempt the vessels. Of course, when there is an inbuilt pressure, it is not easy to open, but you need to follow such precautions when you use bomb calorimeter. Please go ahead, Ujash.
Result and discussion of the experiment. The experiment begins with the isolation of sunflower oil from sunflower seeds. A brief pre-lab lecture covers the details of this extraction, emphasizing the aliphatic nature of the extract and the fact that its structure affords a facile isolation of the oil using a simple hydrocarbon solvent that are hexanes by the way of softlet extraction. This softlet methodology here is attractive as it richly demonstrates the concept of continual extraction, reinforcing the partitioning equilibrium concept first encountered in the organic chemistry laboratory course. It is worth noting here that the yield of actual sunflower oil from the seeds is fast, that is 2 to 4 ml. As such, it is important that the instructor augmented with off-the-shelf sunflower oil. Initially, we thought the augmentation was not desirable, but soon realized the value of students directly observing the low yield of triglyceride, which clearly illustrates the concentration challenges associated with exploiting natural products as feedstock in biofuel production.
Excuse me, Ujash, one highlight here. Ujash in this slide has told how we can get oil or triglycerides. Oil is also called triglyceride. The chemical name of sunflower oil is triglyceride. Okay. How to get from sunflower seeds the oil? By using hexane as the solvent and using softlet extraction. Okay. You should know how the softlet extractor look like. How will we extract in YouTube's you can find. Please go ahead, Ujash.
A battery of tests is performed on each of the fuel samples.
Excuse me. Here battery means not literal battery that we have in laptop or in phone. Battery means a series of a series of power packed means useful. Okay, necessary. A battery of experiments means a bunch of experiments that are useful. It has nothing to do with the literal meaning of battery. Agreed? Do not think that it is battery. Battery of experiments means it has no meaning. Please, Ujash, go ahead.
The normal routine employed in our laboratory is to have each student complete the library of the analysis on one biodiesel sample and one conventional fuel. The samples are initially analyzed via density, refractive index, viscosity, and the cloud point. A summary of typical student data can be found. Density was determined simply by transfer of 100 microliter aliquot via volumetric pipette to a test tube on the analytical balance. Viscometry was determined by employing a Gilmore falling ball viscometer and refractive index by the use of an Edmond optics standard app refractometer. Like the other analysis performed, greater precision was achieved by acquisitions in triplicate with averaging the series of runs. Following a brief demonstration by the instructor, viscometry and refractometry can be readily done independently by the students. The refractive index and density provide the starting point in the analysis of fuel quality. Refractive index may be used to ascertain the efficiency of transesterification and, furthermore, to verify purity. A pure biodiesel is desired to produce reliable means of combustion measurements later in the experiment. All of the BD samples should have similar refractive indices due to their analogous chemical makeup, with the exception of FAMES produced from the palm oil, which has divergent fatty acid source profile. The literature values of biodiesel and number 2 diesel are estimated to be 1.4548 and 1.4650 respectively.
Excuse me, Ujash, have you followed the previous slide carefully? It has wealth of information, you know, as Devansh paper was focused on FTIR, okay? Devansh presented us a beautiful technique called vibrational spectroscopy for the estimation of bioethanol in a mixture of glycerol, in a mixture of gasoline and ethanol, not glycerol and ethanol. It's gasoline and ethanol. That's what Devansh has presented. Ujash has presented a beautiful technique here. Not one technique, but more than one technique. One is viscosity, other is refractive index. Here we have two classes of biodiesels. Biodiesels produced from the sunflower oil and
The other one was number 2 diesel, which was used as a petroleum-based fuel analysis.
yeah, and a comparison is made between the refractive indices values of. Can you please go to the the literature values of biodiesel and number 2 diesel are estimated to be 1.4548 and 1.4650. Number 2 diesel, as I understand, is from palm oil, produced from palm oil. All of the biodiesel samples should have similar refractive indices due to their analogous chemical makeup, with the exception of FAMs produced from palm oil, which has a divergent fatty acid score profile. The next sentence has nothing to do with the preceding sentence. The last sentence is an independent sentence. The literature values for biodiesel and number 2 diesel are estimated to be 1.4548 and 1.4650 respectively. Even the small change at the second decimal point also matters. That's what it means. Okay, please go ahead, Ujash.
Conclusion. The protocol of a project-based preparation and analysis of biodiesel in comparison with a series of conventional fuel sources has been described. The project involves a multifaceted and comparative analysis of various fuel samples that provide broad exposure to key laboratory techniques for undergraduates while providing enrichment of critical chemical concepts. The breadth of this project allows students to evaluate the limitations of methodologies, but also to ascertain the physical properties that lead to the optimization of a critical characteristics that may be interest to the development of a variable alternative fuel. Topics for discussion included mechanistic organic chemistry, intermolecular forces, thermochemistry, chromatography, spectroscopic interpretation, or molecular modeling. Students complete the exercise by using the collective results to preliminarily identify the suggested alternative fuel source and to communicate the findings via a memorandum to Air Force leadership, and by compiling results in the form of comprehensive supporting information document.
Give a big hand to our friend Ujash for a very elegant and clear presentation. Thank you, Lakot, for a very clear presentation. I congratulate you for presenting to us such a complicated subject so easily. We could follow you very well, and thank you very much for the presentation.
Thank you so much.
But the problem, I tell you, some important information is missing. The whole of the paper, the whole of the paper contained one beautiful table that make a comparison between the energy content of biodiesel relative to petrol, gasoline, kerosene, jet fuel. As Penal Pandey has neglected the table, saying that copyright. But we need. No, I tell you, it's possible. I will not accept such explanations. If something is not happening, you should have updated me and I would have provided you a solution. Just control screen print hota hai na. Don't you have that screen print option? Control, press screen print, go to Photoshop and cut the figure and paste it. There are 120 options available. I will not accept such things. Such vital information should not be neglected. The whole of the paper contains one beautiful table. Penal has neglected that table. Ujash has neglected that table. Ujash, do you have the table or not in the paper? Yes. It shows a beautiful comparison. that biodiesel is indeed a potential contender to gasoline. That bus we have missed. I do not want such data to be missed in your subsequent presentations. If there are any copyright permissions, you should tell me and I will tell you a solution to overcome the problem. Because there are some hurdles, will you stop your journey? No. You should ask me if you have any problem and I will provide you 100 solutions. That is why I am here. Thank you, Ujash.